Now we'll be learning about the doubly linked list. So here we're going to see each node contains the pointer to the previous as well as to the next in the sequence. So the pointer can move in both direction. So here we're going to see, you can see that this 20 node is there. It has one pointer that is called as previous and this one is called next. So that's in the singly linked list, only next pointer was there, that is the next reference was there, and this header is going to point to where it's going to contain null, and this is going to contain that the previous, like this is the next, and it's going to contain the 15th reference over here, right? And this is going to contain the reference of 20. So this is how the linked list is here. Two connection is done, right? Now after that, if you see where it's used, basically it's used, doubly linked list is used in redo and undo. So useful for the redo and undo functions in tools like IDE, Notepad, etc. that you do, that's done by doubly linked list. So back and forward, you do back and forward function implementation in browser. So that's going to be the doubly linked list use. Now what I'm going to do is I'm going to jump to the whiteboard and we'll understand how insertion, deletion and everything is going to happen, and we will jump to the VS Code and we'll try to solve the things. Let's jump to the VS Code now. Like we came to whiteboard. Now we'll see how insertion and each and everything happens and we're going to solve it. So let's say we have this one node as a 10th node, 20, 30. So this is called as what? This is previous of 20 and this is next of 20. Same thing, this is the previous and this one is next. Okay, same for all the nodes. Suppose I want to add element at the head of the linked list. So what I have to do, right? That is a basic question. Suppose this is already there. Suppose this node is there and I want to add at the head. Add at the head means adding here. At the tail means adding over here. So we're going to see each thing. We already saw this thing in singly linked list. So same kind of implementation is definitely going to be there. So if I add over here, so instead of null, I have to connect this to here, and instead of this null, I have to connect this to here. And you can see in the constructor, what is going to be there is, in constructor, the head previous is going to point to null, and this tails next is going to point to null. So after this is going to be connected to the head of the linked list. Okay, head of the doubly linked list. Now if I go forward, suppose I want to add at the tail. Suppose this is the head, this is the tail, and you want to add at the tail. So what you have to do, instead of null, you have to point it to here, and instead of this null, you have to point it to here. So this is adding at the tail, and you have to update the tail also. Same for the head above we saw, right? So we have to update that also, right? Now let's go ahead and see if you want to insert at the middle. Let's say this node you want to insert at the middle. So what you have to do, if you want to insert here, let's say suppose you want to insert over here, so what I have to do is I have to iterate to that position first, isn't it? This position I have to iterate, and I'll be naming as a temporary node. And what I'll do is, instead of connecting these two, what I'll do is one connection will be done over here, and from here one more connection will be going here. So from here one connection will go, and from here also one connection will come. So 4 connections we have to do, and here we do not need to update the head or tail because we're doing insertion at the middle. So this is how insertion at the middle is going to happen. Now if someone says a deletion from the head is going to happen, so how are you going to do it? So if I want to delete this node, let's say, so what I have to do is, if I want to delete this node, what I have to do is I have to point this pointer to null, and I have to get out of it, and I have to update the head after. So that is deletion from the head. Similarly, deletion from the tail means the last pointer will be pointing to null, and I'll be updating the tail. And deletion from the middle means if I want to delete this one, what I have to do is, instead of connecting this line, it will be connection will be happening here, and instead of this connection, this connection would be connecting here. So this we are bypassing it. So that is going to be the deletion from the middle. So now, and searching that we already did, now we're going to do what? We're going to jump to the VS Code and we'll solve these things one by one, and I'll come back here again whenever it's needed. So let's jump to the VS Code and apply each and everything. I'll comment down so that it will be very, very easy. Similarly, we'll cover the implementation. So let's jump to the VS Code. So we jump to the VS Code. Now I'll delete this and I'll create one file that is going to be doubly linked list, that is dll.java. All right. So we created the Java, like that class name. So what I'll do is I'll come out of it and I'll give some space to it. So at the last, I can write the main method inside that. Okay. Here what I'll do is I'll create a class. This is doubly linked list. So what I'll do is I'll create a class named as doubly linked list. Okay. So doubly linked list. Okay, inside this, we're going to define each and everything. The first thing is going to define is the node constructor, whatever the data members are, then each and everything we will do. So what I'm going to do is here I'm going to declare inner class representing a node in the doubly linked list. Okay, so what I have to do for that, I have to create a class for that class node I'm going to create. Okay, and in that class node I'm going to declare the data member. So what is going to be there? Public. We already remember that in single linked list we already did it. So in data, this is what data node. Next we're going to write public node. Here I'm going to write previous. One pointer that is I'm taking, that is previous. In the single linked list we only took the next, right? Here I'm going to put previous also. So here what is the use of this? Reference to the, I'll write one more, public node, and that's going to be what? It's going to be the next, and this is reference to the next node. All right, this is the data members we declared. Now I'm going to write constructor to create a new node with given data. Okay, so how to create a constructor? What is the name of the constructor? Is going to be, constructor name is definitely going to be node only, because we are writing inside the node class. So constructor name is the name of the class. So I'll write enter data over here, whatever we're passing here, and here we're going to write, we're going to initialize this dot data, that's going to be data only, and I'm going to initialize this dot previous, that's going to be what? Initially it's going to be null for the whatever we create, and here going to write this dot next equals to null. Okay, so this is, I have to change to this. All right, now these are we initialized with it. Okay, now I'll come out of it and I'll create a global head and tail, right? So I have to write, I have to reference to the head, that is the first node of the list, and I'll reference to the tail, that is last node of the list. What I'll write is for that public node, and I'll write head. This is what? Reference to the head or first node of the list. Similarly, I'll create public node tail. This is going to reference what? Reference to the tail or last node of the list. Okay, this much is clear. Now what I'm going to do is I'm going to create a constructor to initialize an empty doubly linked list. What I'm going to do is constructor to initialize each and everything I'm doing, so that everything we did in single linked list. Initialize an empty doubly linked list. Okay, now I have to create a constructor. So constructor name is definitely going to be doubly linked list, right? So I'm going to write the access modifier of that. Let's say public, and name of the linked list is going to be doubly linked list. And in this constructor, I'm going to initialize it. So I'll write this dot head is going to point to null, and this dot tail is going to point to null. Okay. Now what I'm going to do is I have to write the method to insert the node at the head of the doubly linked list. So method to insert the node at the head of the link. How to do it? So we're going to write create the public method. That method I'm going to create. So public void, let's say insert at head. Okay, and in this I'm going to pass data in it. Okay, so data we inserted. Now what I have to do is I have to create the node first before inserting. So I'll create node. So node, let's say new node I create, and new node, and I pass that data in it. Okay, now what I'm going to do is I'm going to set the next of the new node to the current head. So new node of next, that is going to point to the head, right? Because we are inserting at the head. So what we are doing is that if I go to the whiteboard, if you can see over here, we are right now inserting at the head. It means this node, if you can see, this is the new node, that is temp is written, right? So this 20's next is going to point to where? Head. That is what we have written over there. All right. And we have to update the head also, right? Before updating the head, we have to check if the node is empty or not. That way also we cover that. Okay. And we have to do what? We have to connect this one also. So head dot previous is going to come to new node, right? And we're going to update the tail also, and we're going to update the head also. Both updation we're going to do. All right, this is done. So this is what set the next of the new node to the current head. Okay. Now what I have to do is I'm going to write one if statement. Here I'm going to check if head is not equals to null. I'm going to check if the head is null or not. Okay, so if the head is null, what I'm going to do is head dot previous I'm going to connect to new node. If head is not null, then what I'm going to do is I'll update the previous of the current head to the new node, right? So here I'll write what head dot previous I'm going to connect to what new node. So this is what update the previous of the current head to the new node. Okay, else if it is empty, what I'm going to do, else I'm going to update the tail, and I'll definitely update the head also. It means if it is empty and we entered that, so that one element is going to be head, and that one element only is going to be tail, right? So here covering this is the exception case we are covering. So we'll update the head also, right? Here head equals to new node. So tail equals to new node means if the list was empty, update the tail as new node. Why? Because one node is there, that is the head and that is the tail, and here we are updating the head of the new node. Update the head of the head to the, not of the, to the new node. Okay, this much. This is the insertion at the head. Now what I'm going to do is I'm going to come out of it. I'm going to write method to insert node at the tail. Suppose I want to insert at the tail of the doubly linked list. So method to insert the node at the tail of. Okay, so we're going to create the method for that. So let's say, public void insert at tail, and here I'm going to insert the data in it. Right? So what I have to do, we will create the node first, isn't it? Same thing we're going to do, node, new node. I create new node and new keyword and node. I'm going to pass the data in it. I created the node. This is the node creation. That whichever data we want to enter. Now what I'm going to do is new node previous is going to come to tail, isn't it? We are writing up adding at the tail, right? So suppose we are inserting this one. So if this is new node, that is temp is we are writing as new node, that previous of temp is going to come to this, and tail next is going to come to new node, isn't it? Both thing we have to do, but we have to check if it is empty or not. If it is empty, then only one node is going to be entered, then that is going to be head and that is going to be tail, right? Same thing that we did insert at the tail. So that same thing we're going to do here also. Okay, so what I'll do is new node dot previous is going to connect to tail. This is the connection we are doing. So this is what set the previous of new node to the tail. This is what, this is the connection one. Okay, now if the tail is empty, it means if the linked list was empty, right? If the tail is not equals to null, that time what I have to do is I'll give tail dot next to the new node, right? I'll write tail dot if the linked list is not empty, right? So tail dot next, this is the second connection we are doing, equals to new node. So this is the second connection we did. So this is what update the next of the current tail to the new node. Okay, now this is done. If the linked list was empty, then what to do, I have to update the head also here. So that is going to be head, right? New node, and that is going to tail. That like obviously we're going to cover after that, right? So we're going to, this is what this means was, if the list was empty, update the head to the new node. That new node is going to be head and that new node is going to be tail also, right? And after coming out of it, we are inserting at the tail. Definitely we have to update the tail also. Tail equals to new node, right? So this is what update tail as the node. Okay, this is insert at the tail. Now suppose I want to write a method to insert some position, right? That we did in singly linked list also. So what I'm going to do is here I'm going to write method to insert a new node at a specific position in the linked list. So what I have to do is I'll create the function for that. I'll write public static, not static, will not static, right? We'll write void, okay, public void insert at, let's say, middle, that we want to insert the middle. So here we will take two parameters, like that is int position, that where we want to enter and what data we want to enter. Okay, this is the thing is there. Now what I have to do is I have to check if the position is one, that is insertion at the tail, and if the position is at the last position, right, if it's entered the last, so that is insert at the tail. So we have written all those two functions above, right? So what I can do is if position is equals to less than equals to 1, then what I have to do, here I have to write insert at head and data we have to enter. This is what insertion. So if the position is 1 or less, so we are inserting at the head, right? We are calling the function, right? Insert at head. Okay. Else if one more condition we're going to write, if position is greater than size, and this function will create same as we have did the single link. This is, remember, it means it is at the last, right? So we'll call the insert at tail, and this is going to be give the data. So this is what, if the position is, if the position is greater than the size of the linked list, then insert at tail function will be called. Okay, this you understand, all right? Now if you are entering at the middle of the, like, not at the head, not at the tail, it's done. So in the else condition, that's going to be covered. Now before doing that, we have to iterate to that position after that insertion is going to happen, right? And there will be 4 connections. So I have to create the node and I have to reach that position, and after that we have to do all the connections, right? So let's create the node first. Let's create the node. New node I want to enter. Let's say new node I've created. Okay, now what I'll do is I'll write the new keyword, and that I'll create node of data. Okay, now this is the node creation done. Now I have to go to that position first, wherever I want to enter. So for that, what I'll do is I'll write, I'll take one temporary node that's going to iterate actually. So here I'm going to take, node of type temporary, that's going to be there, and that's going to point initially to the head. Okay, and from here we're going to iterate and we're going to go to there. So like I'll write int count is equals to 1 initially. All right, and what I want to do is, while count is less than position minus 1, position minus 1, if I write this, it means we want to reach that point. If it is 1, then I want to update the temp every time. So temp equals to temp dot next, that's going to be right, temp dot next. So this is the going to the iterate, right? So it is what traversal, this is what traversal the list to find the position to enter. Okay, now after reaching that position, what I'll write is I'll write count plus plus. Okay, this is where you're going to get that position. After going to that position, we already created the node. I have to do the linking, right? So let's see in the whiteboard. Okay, so we are doing what? We are entering over here. Okay, if I remove this, let me remove all this and I'll try to show it again that what are those connections would be. Okay, so we want to insert this one, right? Node that is going to take the new node. Let's say we're going to take the new node as a name because we're taking everywhere. So what I'm going to do is new node dot next is going to the temp. If this is the template, this is the position is found. So temp next is this one. So new node dot temp next is going to be this. So this connection will be called as what? New node dot next. This is the next of new node, right? Equals to temp dot next. This is what? Next of temp, right? Then after that, I'm going to write new node dot previous is going to be temp. So this is the previous of new node, and this is going to be the temp. And temp dot next dot previous, that is from here I'm to do the connection, this one, right? So what are writing? Temp next is this one, and its previous is this one, and it's going to be connected to a new node. And one more connection that is left, that is I have to do temp dot next. I have to do as these four connections I have to do. So let's go to the VS Code and write all the four connection. All right. So let's say I'm writing new node dot next. I'm going to write to add temp dot next. So this is the one connection. This is what? Set the next of the new node to the next of the current node. Next of the node. Okay, this is one connection. Four connection we have to do. And what I'll do is I'll do new node dot previous is going to connect to where? Temp. That is the temp node is there. So this is what? Set the previous, set the previous of the new node to the current node. Okay, this two connection is done. Now I'll do is from the temp dot next dot previous, this is going to connect to new node. I already shown what I'm talking about this. So this is what? Update the previous of the next node to the new node. Update the previous of the next node to the new node. So okay, now I have to write one more connection that is going to be temp dot next, that is going to come to the new node. Okay, this is what? Update the next of the current node. Update the next of the current node to the new node. Okay, so this is all done at the insertion at the middle. All right, and I'll come out of it. Now we'll do the deletion thing. So we're going to write method to delete a node at a specific position. Suppose you want to delete, right, in the doubly linked list. Suppose you want to delete, what you have to do? So we already know that how to delete it, right? I already talked about that. So deletion can be done from the position one, deletion can be at the last, from the last, and deletion can be that thing, right? So we will write that thing one by one. So if, okay, we're going to write the function name. So I'll write public void, and I'm going to write, let's say, delete node, and in this I want to write the position, in which position I want to delete it. Okay, let's go into it and write all the, if the position is 1, if position is equals to 1, it means we want to delete the first node, right? So I'll check if head equals to tail, right? If head equals to tail, it means there is only one node, so we'll update the tail to be null, right? So I'll check if the head is equals to tail. If the head is equal to tail, what I'm going to do is I will update the tail to be null. Okay. So if there is one node only, update the tail to null, because we are doing the deletion. We can update the head also to be null, isn't it? Okay. Else, what I'm going to do? Else, I'm going to write head next previous is going to be null. Head, because current head is going to be what? Okay, what I'm saying is, if I want to delete this head, right? So if only one element is there, then I have to put it as null, right? If lots of elements there. So what I'm going to do is, this is head next is this one, and previous, this one I have to make it to null, isn't it? Head next is this, and head next dot previous is going to make it null. So this I have to make it null, isn't it? That's why the connection will get broken. So that's what we want to do here. Else, what I want to do is head dot next dot previous, that is going to come as null, right? So this is what, update the previous of the next node to null. Okay, and what we have to do is, after deleting, we have to update it also, right? So after deletion, each and everything, we have to update the head also. I'll come out of it here, and I'll update the head. That head is going to be head dot next, because the next element is going to be the head, right? So this is what, updating the head to the next node. This is what we're going to do, because we have to update the head also, right? Okay, this is if is done. Else if the position is equals to size. If position, so what I have to write is, I have to write as a function, and I have to write the condition here. Okay, if position is equals to size function, that is going to call, we're going to create this function later, right? So if it is this one, means we're deleting from the last. So we'll do what? Update the next of the previous node to be null. Next of what? Like update the next of the previous node, right? We were deleting from the last. Suppose this is getting deleted, it means what I want to do is, we're going to put this as the null, isn't it? So this is which node? If this is tail previous next, right? Tail dot previous dot next is going to be null. This is tail, this is previous, and next we're going to make it null, right? This is what you have to do. So what I'll write is, here I'm going to write tail dot previous dot next, I'm going to make it null. Okay, we made it null. So what does this mean actually? It means update the next of the previous node to null. Node to null. Okay. After updating this, what I have to do, I have to update the tail also, right? So what I'll do, I'll try tail equals to tail dot previous, because now previous one is the new tail, right? This is what update the tail to the previous node. Okay, this is very clear. Now what I'm going to do is, if we are deleting from somewhere else, like it from the middle, so I have to reach that point and I have to do two connections that you already know. I'll create the node, like I'll take one variable, you already know how to iterate it, so I'll take one variable that's going to be current and that's going to be pointed to head, and I'll be taking one more, I'm going to reiterate to that position and I'm going to update it, right? I'm going to take, enter count is equals to 1, and I'll write a while loop. And that while loop will go to that position. So I'll write what count is less than position. It will reach that position. And after reaching that position, I have to delete that. Right? So what I'll write is cur equals to cur dot next current. This is the current element we are talking about. Current dot next. This will do what? Traverse the list to find the node to be deleted. Find the node to be deleted. All right. What I'll do is, after that I'll have to count plus plus. So we actually going to reach to that position. Now after that I have to do the linking. So I have to come out of this, right? I have to come out of this and I have to, suppose I'm deleting, let's say deleting this middle node, right? Okay. So let's come down over here. We have taken, okay, so let me clear it out here, rub it. Okay, and what I have to do is, here suppose, let's say you reach to that point and you want to delete 20. If you want to delete 20, this connection you see, you have to cross it and you have to make as this connection one connection. You have to cross this connection, that this connection is there, and you have to make it as this connection. All right, so how to write this one, right? So what we'll be writing is, current node is going to be the deleted node, right? That's going to be, this is going to be the current. We're going to reach to this position. So we have to connect this one to this. So current, previous, next is going to equate to what? Current next, isn't it? Isn't this line is actually current previous dot next is equals to current next. You can see this is current, previous is this one, and next is this one. We have to connect this one with this one, and this one is what? If this is current, this is current next. So we are doing that, and I have to connect this one. So current next is this one. Current next previous is going to connect to where? Current previous. So that's what we're going to write here. Okay, so it's very easy. I'll write cur dot next dot previous, that's going to connect to cur dot next, and cur dot next dot previous is going to connect to cur dot previous. Okay, one mistake I did, it has to be previous first and then next, right? So cur dot previous dot next, that's going to current dot next, and current. So these lines are what? These are the connections basically. So here update the next of the previous node to the current node, and this one is update the previous of the next node to the previous of the current node. Okay, this is the deletion is done. Now what I have to do is I'll come out of it. This is the function. Okay, I'll come out of it here. Here I have to write the method to calculate the size. Calculate the size. Okay, so we'll write the size function over here. So I'll write, public, let's say int size. We are returning, going to return, and this size function we have created. Okay, now what I'm going to do is initially I'm going to take count is equals to 0. That's going to counting to 0, and after that I'm going to take one temporary node temp, and that is going to come to head. Okay, so here instead of inr it will be int. Okay, now size function we have created. Okay, head. Now what I'll do is I'll write a while loop, and until unless the temp reaches the null, it means it reached the last node out after that, right? So there it's going to end, right? I'll write temp is until unless not equals to null, iterate that while loop, and do what? Count plus plus. Do count plus plus, and you update the temp equals to temp dot next. This is what? Traversal. This is what? So this statement is actually traversal. Traversal to the list to count nodes. Okay, and at the last we're going to return count at the last. Okay, this is the size function. Now if I want to write the printing function, I also can write that, right? So what I'll do is I'll come out of it and I'll write printing function. So I have to print it now. Okay, so what I'll do is I'll write, I'll take public void print function. Okay, in this function, what I'm going to do is I'm going to take a node, temporary node, and that's going to point to head. I'm going to point it to head, and that I'm going to write the while loop again. And that while loop, what I'll do until unless temp is not equals to null, we're going to run this while loop. And what we're going to do is we're going to print the data of that temp. But I'll write system dot out dot println, and here I'm going to write temp dot data. That's going to be where that's going to be printed, and we'll give it here. This is what print the data of each node. Okay, and I have to iterate also, right? Temp equals to temp dot next. So this is going to go to the next. This is traversal of the list to the next node. This is similar to I plus plus that we do in normal iteration. I plus plus equals to I plus 1, right? Same thing that is actually happening over here also. And at the last, what I'll do is for looking good, I'll write system dot out. I'll give one print enter statement so that it look good. Okay, I'll write println, and here I'm going to give nothing. Okay, now I have to write the searching function also, right? So if I want to write searching function, so I'll write method to search for a value the list. So how to write it? So what I'm going to do, I'm going to take it as boolean. So I'll write public boolean, and we're going to write the search function. And in that search function, I want to take the value, whatever the value I want to search for. So I want to take the value as a parameter, and what I want to do is same thing. I want to write node. I want to take temporary value that's going to point to head. And what I'm going to do is I'm going to run a while loop, same while loop. I'm going to run a while loop, and that I'll be writing temp unless temp is equals to null. Run that while loop, and inside that while loop, what you do is I'm going to write one more condition that whatever the node it is iterating temp dot data, if that is equals to value, that time we'll say that is actually there. Otherwise, it is not there, right? So value here we're going to write we're going to return true. So what is actually the condition is? Condition is if the value is found. The value is found, return. If the value is found, return true. And you will do what? You will do the iteration also. If it is not found, go for the next temp dot next one. Go for the next node and check for that. Right? So this is what traversal of the list. Okay. And if after doing the all the while loop it is not found, then return. If it is not found, then return false. If the value is not found, if the value is not found, then return false. So we have written all the function. Now the thing is we will write the main method over here. I'll come out of it here. Okay, and here in this DLL we're going to write the main method. So write public static void main method. I'm going to pass string array inside it, and I'll write args argument. Okay, and in this I'm going to create the object for the doubly linked list. Doubly linked list, and I'm going to write doubly linked list again. That is the object I'm creating, and I'll write new doubly linked list. Okay, this is done. Now I will insert data one by one. So insert at head we're going to do, and each and everything is going to do one by one. So what is object name? Object name is doubly linked list. Doubly linked list dot insert insert at head. Insert at head. Let's say I want to enter 10 over here, right? And I will print the control Z. I'll print the function. So I'll do is doubly linked list dot print function. So I'll hit Control S. Now I'll click on the run button. So let's see if 10 is getting entered or not. So we got that 10 as the like it got entered, right? Now let's say I want to insert at head of that 10. It means it's going to before 10, right? Here it's going to come actually. So if I copy this, and I paste it over here, paste it over here, paste it, paste it. It didn't paste it. Okay, paste it. Control Z. I did something wrong. I have to copy it again. Control C and paste it. Let's say from 10 it's changing to 20. From 10 it is changing to, let's say, 30, 40, 50. And I hit Control S and I'll run the code. So you see after 10, before 10, okay, it's coming to the next line. So we have to make it so that it comes to the next line. So we have to go to the print, and instead of writing ln, I'll write print, and I'll hit Control S now. Now I'll run this. It will look better. So we'll like it will be it visually we can see better, right? Okay. 10 was there. In the head of that we entered 20, head of 20 we entered 30, head of 30 we entered 40, the head of 40 we entered 50. All right, it means this is working very well. Now suppose I want to write doubly linked list I want to insert at the tail. So I want to insert at tail, and the value I want to insert at tail, let's say I want to enter 20 in it. So after 10 is going to come 20, isn't it? So I'll hit Control S and I'll click on run. So after 10 it should come as 20, right? So let's see if it is working or not. It is not working. Why it's not working? It's working, but we didn't print it actually. That's why it is not. That is not visual. It is, we are seeing it. I'll paste it. I'll hit Control S now because we need to print it. Otherwise, how we can see it? It's internal. It is happening, but we have to print it first, right? Okay, you can see 20 is like insert at tail is working. Let's say what I want to do is I want to copy this and paste it 2-3 times so that we enter the value. Okay, so paste it. So from 20 it's going to be 30. Let's say at the tail of 20 30 is going to be added, and here 40 is going to be added at the last. I'll hit Control S and it will add the element. So let's run this and see if it is working or not. So this is printed, we saw, right? Now suppose we want to see what is the head. Let's say system dot out dot println. So in this linked list, if you want to see the head of that linked list and tail of the linked list, how we can do this? I'll write head is, I'm going to write, and that's going to be right plus doubly linked list dot head dot data. So it's going to give the data of the head, right? So I'll click over here so that I'll get more space to write. And what I'll do, I'll just copy this one and I'll try to get the tail also for the linked list, last linked list, right? So here instead of head, I'll be writing, let's say, tail. Okay, instead of head here, I have to write tail. I'll hit Control S and I'll run this code. So head is going to give us 50 and tail is going to give us 40 because link 50 is the first element. You see, this is actually result is giving. Okay, let's say I want to do what? I want to insert, like I'll write that insert at middle, doubly linked list dot insert at middle function I'll be calling, and here let's say I want to enter the element as the first position, that is the first position I want to enter, let's say. So it's going to enter at the head of 50, right? And what I want to enter, let's say 200 I want to enter over here. Okay, now and after that I want to print the linked list also. So what I'll do is I'll just copy this and paste it over here, and after doing this I'll again print head and tail. We'll see if that is getting updated or not, isn't it? So I'll do hit Control S, I'll go above and I'll click on run. Now it should give 200 should come at the first and 200 should give at the head. See, head is coming 200 and 40 is coming as a tail because this is the updated linked list, right? Now let's do other operations also. Let's try to do, you know, I want to write, you know, doubly linked list and insert at middle, and I want to enter, let's say at the position 10. Suppose I want to enter at the position 10. So what I'll do is here I want to print it also, doubly linked list dot print function I want to write. Okay, now I'm going to, after doing this, I'm going to again print the head and tail if it is giving the right result or not. I'll hit Control S, give some backspace and run the program. So after running the program, you know, we have entered at the 10th position, at the last position is we are entering. So here you can see we have entered, okay, it didn't, we have entered 10, right, at the, okay, so one mistake that I did is I have only written 10, right, and I didn't give the value. So you know, I have to give the value also, that is, let's say 100 I am giving as the value. Insert at head, it will be not head, insert at middle I have to write, isn't it? So I want to enter at the last. Now I'll hit Control S. Okay, insert what? Head function was called, so that's why it's giving was unexpected result. Now 100 should get at the last of the linked list, that is after 40 is going to come, because at the 10th position that is going to come, right? So you can see the updated linked list is this one, right? And 200 is the head and 100 is the tail. Now suppose I want to delete the node, so doubly linked list, I'll be calling the doubly linked list dot delete node, and here I'm going to, let's say, delete the first element. That is deleting the first element, which means it's going to delete head as 200 is going to be deleted. So I'll write system.out println, so I'll write doubly linked list, not system.out, doubly linked list dot print function. If I do so, that will do its task, right? So it will delete the first, and I'll hit Control S, I'll go over here and I'll click it here. So you can see that 200 is deleted. Now updated linked list is what? It's 50, right? So that is what we wanted, that we deleted. Suppose we want to delete from other positions, so what I'll do, I'll just copy this and paste it over here. Let's say from the position I want to delete, let's say 3, so it's going to get deleted from the 3. So 1 2 3, 30 is going to be deleted, right? So if I run it, 30 is going to be deleted. Again, run this code. Now if you see, 30 is not there, this 30 is not there, but this 30 that is from the last, it's there, but from after 40, 30 was there here, so that we deleted it. So you can do this way. Let's suppose I write I try to find that what is the, like, if some that element is there or not. So I'll write system.out.println, and here I'm going to write let's say search 30, if 30 is there or not. Yes, 30 is there, I can see, right? So what I'll do is I'll concatenate it, and here I'll call the doubly linked list dot search function, and in that search function we'll give value as 30. So it will give true or false as the answer, right? Here I'll give colon, so it will look good. Okay, all right. Now if I want to search one more element, let's write it and copy it and paste it and see if 100 is there or not in the updated linked list. We cannot see 100 is there, right? So it should return false. I'll hit Control S and I'll click on the run button. So you see, it's okay, 100 is also there, all right, it is there, right? So let's say we want to search 200, it's 200 is there or not. Okay, 100 was actually there, so if I want to search 200 is there in the linked list or not, I'll hit Control S. Now I'll click over the run button and we'll see that 200 is there. Now for 200 it should return false, right? Because 30 is obviously there, but 200 is not there, see, it is returning false. Now let's suppose you want to find the size of the linked list. So you already know that we have declared the size function, so I'll create size variable, and in this I'll be calling the size function, right? So I'll calling the size function, this is, I called it, and I'll write system.out.println, and inside this I'm going to write size of the linked list is going to be what? I have to concatenate it, and I have to write the size variable. So size variable, if I write it, give it over here. So what is the size? You can see 1 2 3 4 5 6 7 8. So it should print 8 as the size of the linked list. If I run this code, so it should give as 8 as the size of the linked list, because we have, okay, it is giving some kind of error. What is that error? Okay, system, it has to be system, so we have written something wrong. I'll hit Control S. Now I will run this code. I'll click cross over there. So see, size of linked list is giving as 8. So this is all about the doubly linked list. Now after this we're going to learn about circular linked list, and we're going to implement the same way, but in circular linked list something is different, so we're going to do that quick, and after that, that is also going to be done. So this is all about doubly linked list. Thank you.